big old Google Hangout, and this is live as well. So
cool. Hi, live people.
Yeah, there's like a live stream as well going on. Yeah, so Todd is you're in Minneapolis?
I am. I'm actually in a little city outside of Minneapolis called Stillwater, but I don't expect anybody to have heard of that.
Okay. Well, he's going to give a presentation tonight on something. I can't remember what it is. It's one of two different presentations, so whichever one he picked out, he'll be going with tonight. Either one is going to be great. I had the pleasure of watching him present. He'll be talking about JavaScript forensics. I had the pleasure of watching him present at MiniWebCon, which is in Minnesota. MiniWebCon in Minnesota. A great presentation on unit testing and testing in general, actually. So it's really cool. He's got a special affinity for testing because he runs a company called Track.js. At least last time I checked, he runs it. So they do like JavaScript debugging code. He can describe it a lot better than I can, but
oh, and I will.
He will. So he will be giving a presentation on this. And apologize if you hear ice for a little bit. I've got to go get myself another drink. Okay, y'all.
Drinks are important.
Boy, yes, they make your audience much happier.
So I want to respect everybody's time. How much time are you expect? What time does everybody need to get out of here?
3 hours.
3 hours. I do not have 3 hours of content.
I
we could play StarCraft or something for the last 2.
Just do 30 minutes.
Okay. Sounds good.
8:45 is the limit.
All right. I will make sure I am done by 8:45. Okay. So this is JavaScript forensics, and it's a talk about how it all goes wrong. It's about how do we diagnose and do we debug production JavaScript problems. So I'm Todd Gardner. This is what I look like on the internet. I'm on Twitter at Todd H. Gardner. Feel free to heckle me there or, tell me I'm terribly wrong, as I frequently am. Let's see, how do I move? There we go. So why is this important? It's important because everybody is bad at JavaScript. I'm terrible at JavaScript. There's really smart people at all of these companies who are really, really smart. And they all release stuff into production that had JavaScript problems. Everybody releases things into production with JavaScript errors. And I haven't found any company that is the shining beacon of we are error proof. These are really smart companies with really smart people at them. And so the problem is that there's just tons of really broken JavaScript on the web. So recently I crunched a bunch of numbers from data that I have access to internally with Track.js and calculated on average across all of our different customers, how often do people actually have an error for a page view? And what we found was it's about 40% of the time on average. 40% of the time, any given page hit on the web will result in some sort of JavaScript error. That's huge. I mean, that includes some test environments, and that includes some big production web applications. And so the mode here is really big, but on average, 40% of page views result in some sort of JavaScript error. As developers, all we really want to do is we want to ship some awesome software. We're trying to make the next great version of our products. You're probably working at a company or a startup, or you have your own thing, and you're building something in JavaScript, which is why you're here. And it's going to be the new, shiny, faster, more interactive, highly deployable, offline, all the fancy buzzwords version of the product that you're trying to imagine. As developers, we're just trying to get that out the door. But there's all of these really treacherous things that are trying to get into our way. There's a few different browsers that we have to deal with. And even if you have the smallest of user bases, you have multiple browsers that you need to deal with. Or if you're deciding you don't care about one of them, you're leaving a huge chunk of the internet's population there to not experience your app. And to help us with these browsers, we have several different third-party scripts that you're probably going to be bringing in for various parts of your app. You might bring in, an error monitoring third-party script like Track.js. You might bring in a payment provider like Stripe. You might have social networks like Twitter or Facebook. You might have content injection or any number of third-party scripts that you bring into your site to make it even better and to deliver more value. And we have lots of application frameworks to deal with this. And each time we bring in or decide on a framework to use, we've introduced new constraints and new challenges on how those frameworks are going to play with the browsers and with the third-party scripts we need to deal with. And then we have an army of JavaScript libraries that we use to actually solve the tactical problems of our app. And the problem with all of these JavaScript libraries is there's huge variations in quality and support throughout the ones that we use. And so we bring all of these different things together, and it's no wonder how many terrible JavaScript apps get shipped into production. Is anybody happy with the state of the web today compared to 3 years ago? Like, there are so many broken websites out today. And it's because we have this complex environment of browser conflicts and third-party scripts and injection, and everybody's using JavaScript for everything, and nobody knows how to do it any well. So I want to talk about my own disaster, Soliloquy. So Soliloquy, this is a little side project I have, and this is going to be great. I'd like to show you this disaster. Do you guys see Soliloquy?
Yep.
All right. So this is my social network. This is my next project. And Soliloquy is kind of like Twitter. You can see that it's got a place for you to post your status updates like Twitter. It's got this awesome timeline like Twitter. It's got these sweet inline ads, which I know you love on Twitter. And I have awesome advertisers lined up for things like cats and bacon.
Hey, Todd, just a second.
Oh.
I know. You were finally getting a roll.
I know. You broke me mid-joke.
But, I obviously was paying attention. Look at this. Okay, now.
Hello, hello, hello.
Oh, that's so much better.
Hello.
You're talking about something about cats and bacon?
I was.
Okay.
I was talking about Soliloquy in my own. Oh, I got it. I'm going to have to mute you guys so that I can hear.
Yep.
Okay, all good? All right. So, all right. So Soliloquy, I have these awesome inline ads, and I've got a ton of like cool advertising partners lined up for things like cats. We're desperate for you to pet them. And bacon, because everybody loves bacon. And even David Hasselhoff. So I have all of these awesome advertisers lined up for Soliloquy. And Soliloquy, although I copied a lot of things from Twitter, and Soliloquy is going to be really big, I did leave out probably the most irritating part about Twitter. Other people. Because with Soliloquy, it's all about you. Only you can see your updates, and only you can post updates. And so this is going to be huge. This is going to be this great thing. And so while I'm working on Soliloquy, I'm using another project that I built to help me get this off the ground and make sure that it's going to work great. And that's a project called Track.js, which is a JavaScript error monitoring tool. And so what Track.js is if you have this awesome front-end application, Track.js can plug in and help you understand when your customers are encountering problems. So we'll tell you interesting things like how many customers are running into an error, how many customers are affected by a particular error, what are your troublesome browsers and pages, and we give you tons of interesting context about how to actually debug them. And so I'm going to use that a little bit here to debug Soliloquy. Because with Track.js, I found, well, there's 6 pictures up here, but I only have time to talk to you about 5. 5 outlaws, 5 of the most common JavaScript errors that applications run into, and how to debug them and how to fix them. So that's what we're going to talk about today. We are going to go through these outlaws. We are going to see how they manifest themselves inside of Soliloquy. We're going to debug them, and we're going to fix them. Sound good? Thumbs up? Awesome. All right, so let's move on to our first error. This is John Doe, and it comes up to us as script error. Script error is the first thing that you probably ever have to deal with as soon as you begin trying to programmatically capture errors from a JavaScript application. And so we don't really know what's causing this, but we know it happens a lot. So I just launched Soliloquy, and already I have 2,400 script errors coming in across all of these different browsers, all these fairly modern browsers that I would expect to be able to give me better information than just script error. That doesn't tell me anything. Like, I don't have a stack trace. I don't know what went wrong. I just, bleh, nothing. So let's take a look at Soliloquy and see if we can figure out what exactly is going on. So if I take a look here and run Soliloquy, well, there doesn't seem to be anything wrong, but if we pop open the dev tools, is this big enough for everybody? I don't know what size screen you have. Again, I can't hear you. It's good? All right. So if we pop open the console here, we see a bunch of stuff getting printed out into the console when I load Soliloquy. One of the things you might notice right away is that there's just a lot of console messages. That's kind of my style when I write a JavaScript app. I tend to put a lot of debugging statements in my code because I think they're really valuable when I pick up a piece of software later to try and understand what it's doing. And it's also just really good debugging information when something goes wrong. And so I see a couple of errors right away in the console. I see that Chrome caught this uncaught reference error, get random add is not defined. But the thing that we actually recorded, the thing that actually got sent to our server is script error. Now, I want to show you why there's this difference. So let's take a look at some code here quick. The size good on that? Bigger? That's very big. All right, let's see if I can figure out what's going on. Okay, so here is my quick and dirty representation of how I'm capturing errors programmatically. So the default way to capture errors that works everywhere, works in every browser, is to attach a function to window.onError. When the browser gets an error and it just doesn't know what to do with it, it's not caught anywhere in your app, it's funneled to window.onError. And so all I'm doing for the purpose of this demonstration is I'm just taking whatever arguments get passed to window.onError and I'm printing them out into console so we can see it. But this is the information that's available to us about errors programmatically. And so if we go back to Soliloquy and look at it, what we recorded about an error is this object here, script error, nothing, 0, 0, null. So nothing at all. Programmatically, what was available to us was nothing at all, even though Chrome itself knew a ton of good data about this error. Look, it knew the name, it knew the file, it had a stack trace, it had tons of good information. And so how do we solve for script error? So script error comes, or the important thing about script error is not necessarily what the error is in the file, but where the file is. So this error is coming from this file called sidebar add provider. And if we look at where the sidebar add provider is coming from, that's not what I meant to do. Reveal a navigator. If we look where sidebar add provider is coming from, it's being served from this domain called ads.local port 3000, as opposed to Soliloquy itself, which is being served off of localhost port 3000. So what we've run afoul here is the same origin policy of the browser. Because this page, Soliloquy, the app, was loaded from localhost origin. But this JavaScript was running inside of the ads.local origin. And so the same origin policy on the browser said, uh-oh, there's two different things going on. I don't want information leaking between these origins, so I'm going to obfuscate that error. That's why you get script error. Script error is the browser obfuscating an error that occurred into a different origin. Now, there's a cool way we can get around this that's supported in most modern browsers, and we can put an exception to the same origin policy. There's two different sides of this. First, we have to ask the domain ads.local to allow us to do this exception. And so we do that by attaching the CORS headers when we serve these files. So the cross-origin resource sharing headers. If we look at how this is served, you can see that these files were actually already served. Sidebar add provider. These files were served already with these access control allow headers and access control allow origin. These are the cross-origin headers that tell the browser, hey, we're cool. You can run this JavaScript file from anywhere. We don't mind. Most third-party scripts will already serve these by default, and popular CDNs and domain systems will have easy tutorials on how to set this up. But the second half of this is we actually need to teach the browser that we want to allow this to run. And so to do that, we need to make a minor code change. If we look here at the bottom of my index file, I see all of the different scripts that are being loaded as part of Soliloquy. You see everything is actually being loaded from a different origin. I have my main library files and my app itself being loaded from cdn.soliloquy.local, whereas I have a couple of different ads coming from the ads.local domain. And so I'm going to have this cross-origin problem everywhere. So there's a new attribute that's been introduced into the HTML spec called cross-origin, which is for specifically this purpose on script tags. And so if we decorate these with saying cross-origin anonymous, there's an authenticated mode that you can use for this that's out in the docs if you're interested. But for our case, we're just going to use anonymous. We will tell the browser to go ahead and look for those cross-origin headers when fetching these files. And if everything matches up, do not obfuscate errors. So I'm just going to paste this around in front of everybody real quick. I think that'll work. And if we go back to the console and refresh this page, now we haven't actually fixed the error, but what you'll notice is that what we were able to record suddenly got a lot better. What we're actually able to record now is uncaught reference error, get random add is not defined. And we know it's from sidebar add provider on this line in this column. And we have a full stack trace, which is awesome. Now we can actually get real debugging information programmatically and deliver it back into our system so that we can understand what's going on. So script error, AKA line 1. This is the first error that you probably need to solve when trying to understand client-side errors. It's incredibly noisy. It's going to drown out anything, any good information you want to deal with. And it comes whenever you're using a third-party script or loading from a CDN. Anytime that you're loading JavaScript from a different origin, you're going to have this problem. Now, the cross-origin decorator doesn't work in every browser, and it only works if the file is also served with the CORS headers. But it can give you a lot better information. If you're having debugging problems, you can also try just collapsing the scripts down to be served from the same domain, which does have some performance implications, but it might be worth it for you in the short term to debug a complex problem. Let's move on to the next error, Jane Doe. This is the error that we were seeing in console before. This get random ads is not defined. And it seems to be happening everywhere. It seems to be happening on the initial page load of our app. But the weird thing about this is that it started happening real suddenly. As in, I'd had Soliloquy out for a little while, and I didn't make any changes. We did not have a release to any of our code, but all of a sudden, it's up 500% over yesterday. We just got a flood of these errors, but no changes were made. So let's dig in and see if we can figure out what's happening with it. So if we look here at what Chrome is able to tell us, we see get random add is not defined. And it's coming from this sidebar add provider, which again, if you remember, is not our script. This is something that I'm loading from a third party, from my advertising provider. And it's trying to call this function, this get random add, which Chrome is telling me doesn't exist, which is very helpful. We're not going to be able to get an ad if that function doesn't exist. So if we just take a look around this file here, we can see that, hey, there's this other function called get random ads. Get random add. I wonder if this is just like a typo. So maybe we just pull this thing down and see if we can make a change locally. So here's get random add, another call to get random add. Let's just maybe correct the typo. See if it works. Oh, hey, look at that. Look at all those ads. Now we have a whole new class of ads on our page. We have this annoying sidebar of David Hasselhoff, bears and bacon going down the side of my page. And this was caused by just a stupid little mistake, like the kind we've all made 100 times. You know, an accidental typo in a function name. Maybe somebody accidentally hit the S key when they were trying to save a file. Not that that ever happens, and entered it into the file. But what's important to note here is that this happened outside of my control. Like, I didn't know that a change was being pushed to this advertising script. I didn't have it go through my change control process, or I didn't notify my customers that this thing was going to happen. Third-party script changes happen outside of your control, and they can break your application just like any of your code is capable of breaking your application. Third-party errors this is uncontrolled changes from any time you bring in a third party. And it's a risk that we need to balance with any time we bring in a script. There is a cost every time you go and you reach out to a third party to pull in those scripts. They can now break your page without you knowing. You have given them control to execute code on your page that is entirely under their control, and you need to be aware of it. Let's move on to another error. Now that we have the global errors out of the way, we can start focusing on subtle user behavior errors. And so we have another Jane Doe. And this error started showing up in our monitoring as cannot read property, destroy of undefined. And what's interesting about this error is that we have a good correlation with an action. Is that almost every time this error occurs is right after the user clicks on this button in our application. So let's see if we can recreate this JS delete statement button. I happen to know that that button is this little garbage can right here. So if we go ahead and try and click on that, let me make sure we can see our console so we can see cool stuff. And we delete it. Stuff broke. We saw a console message that we were attempting to delete a statement, and then we got a type error, this cannot read property, destroy of undefined, which is exactly what we saw in our monitoring. So let's look at this and see if we can debug what's going on. So Chrome's got some awesome debugging tools, as I'm sure you know. So I can just, right here in the console, I can pop down and see the stack trace about what's going on. Unfortunately, this stack trace is not all that meaningful. It says there's some anonymous function on line 30 of statement view that blew up. But I want more context than that. So probably my favorite thing that Chrome has released in the last 6 months is this little checkbox right here. Has anybody turned on this checkbox right here? It's pretty amazing. So here in your Sources tab, you can hit this checkbox to turn on asynchronous stack traces. These are stack traces that will span across callbacks, across timed events. So you can see how did things actually get wired up. It's really cool. Let me show you. So now I'm going to refresh it with the async stack turned on. And I'm going to try and delete this statement again. And now when we pop open this error and we take a look at the stack trace, check out all of the cool stuff we can see. So we still know that this was an anonymous function on statement view JS line 30. But I can see that this anonymous function was passed into set timeout. That set timeout was wired up in this function called onDelete, also on line 30. OnDelete was called as part of an event dispatch, which is obviously me clicking on this button. So if we take a look at the statement view JS line 30, that's our smoking gun. That's where the problem lies. So if we take a look at the code itself, here's our line. And right away, there is a very obvious code smell here. And it's the use of the word this inside of this function, right? So we've passed a callback into some other function. And inside of that callback, we've referenced the word this. And so this is not going to be what we think it is when this callback comes back. This is going to be window or the global object or the event or something other than this object that we are obviously implying that it was going to be. So let's look at some ways we could fix this. Let me pop open to the real code. Statement Vue.js. Here we go. So here we have the use of this inside of a callback. Well, so there's a couple of different ways we can solve this. Probably the oldest, most well-documented is to do something like var that equals this or var self equals this, depending on which JavaScript book you might have read first. And that would give you all kinds of options with the closure is now you have a pointer to the value of this, and you could do that.model.destroy. In this case, being that I'm only using it once, I think it's a little bit more obvious to do something like var model equals this dot model and just reference model.destroy. Or if we want to be super cool and trendy and new, we could just bind the value of this when this function gets executed using some newer syntax where we can just say, hey, this function, we want to bind this to it. So that every time this function gets called, the value of this on the inside will be the same as the value of this on the outside, which is pretty cool. Except this won't work in very many browsers, or in anything except the latest browsers. And so if we wanted a more cross-functional way to do this, we could use a Lodash or an underscore polyfill for that and say, hey, we want to bind this function to the value this. And that will essentially allow us to do the same thing. So now that we've bound up the value of this, and we'll actually be able to call model.destroy. If we take a look at our code again, we try and delete one of these lines. Hey, look, we can delete and no errors occur. Hey, we can delete all day. We can delete all the way to David Hasselhoff. This was a context error. And even all the way to production, this is one of the most common JavaScript errors that we ever capture. It happens anytime you have a functional argument where you are passing a function around into something else and referencing the word this. You'll frequently see things like some variable is not defined, or function is undefined, or undefined is not a function, or similar type errors. And it happens anytime you have callbacks or promises. These sort of errors can typically be discovered if you had a really robust test suite, although JavaScript applications of significant size tend to have so many different pathways through the code that it's almost impossible to test it all. And so having a solid monitoring tool to check when you miss a code path that happens in production is valuable. Let's take a look at another error. Here we have another Jane Doe. Now this one, this a text substring is not a function. This is pretty isolated. It doesn't happen very often. In fact, it happened 2,000 times, but it only happened to one person. One poor person had just a really bad time. And so because we're using Direct.js on this, I've captured who this person is. And so we're going to take a look at this error and see if we can recreate it. So I'm going to load up that customer's account, and we're going to see what we can do. How am I doing on time? I have 5 minutes left? Dang. All right, we're going to roll through this one real quick. All right, we have an error. Everything's broken. A.text.substring is not a function for this person, and they don't see anything at all. If we look here as to where this is coming from, it's coming from statement model.js. Because I had the async stack trace turned on, they got a ton of cool context here. So I can see all kinds of stuff in this stack trace. Ultimately, it was an anonymous function that was passed into Lodash map. We were executing some sort of parse function that got called in response to an XML HP request finishing. So some AJAX finished, and we tried to parse it, and it blew up. So if we take a look here at the code itself, we can see here's the line that's failing, and it's this substring is not working. So we're expecting the data that comes back from this AJAX to be something we can iterate over, like a collection of objects, and those objects should have a string text property on them. And that's there has this implicit assumption about the shape of the data here. the data that is actually coming down, if we just go here to the source and put a little breakpoint right on it, if we take a look at the response object that's actually coming in, oh, it's it's this. It's called A because it's complex. It's just A. I'm gonna skip over that for now because I only have 5 minutes. All right, so the object that's actually coming down is an array of objects. And those objects do have a text property, but that property is a number. It's the number 42. And so somewhere along the line, either I let invalid data in, I let this user submit a number value into my API, or maybe my API changed. Maybe I'm calling some third party or some other organization inside of my company and they changed their API. But my JavaScript had some implicit assumptions about the shape of this data. So if I go here and we take a look at our code, which is in statement model, and take a look at this parts function, we should probably be a little bit more tolerant of data here. So item.text might not be a string sometimes. And so if item.text and item and it's string item.text. So if there is an item.text, but it's not a string, then let's just set item.text to bad data. So now if we reload the page, well, they can still, they can see their bad data. I can show them more ads. We're not getting an error, but somehow we need to fix our backend problem that allowed this bad data to creep in. Fundamentally, the problem here was that we had a data contract error, is the API changed its syntax or changed its expectations under us. And this can result in all kinds of terrible production faults or cross-site scripting attacks. And happens anytime that there's a third-party relationship or two different parties working on the client side and the server side, either because it's an outsourced third party or because it's just a separate team inside of your organization. These are really difficult to test for every possibility, because there's just so many variables that can change across a large API. All right, I am running out of time quickly, so I'm going to skip this last one. And just kind of give you a general recap of what we talked about since I ran out of time. I apologize. All right, so the JavaScript outlaws we just talked about were the script error because of browser obfuscation hiding the real errors, third-party errors, errors being introduced into your application because third parties can make changes to your code when you're accepting their scripts from their domains. Context errors, using the value this inside of a callback function. Data errors, when the API that you're calling to changes. Loading errors, which I really didn't get a chance to cover very thoroughly, but loading errors are when some of your application fails to load due to a faulty CDN or a bad network connection. What happens if only one of your scripts fails to load on your page, and what state is your application left in? And memory error, which is another one I was not able to catch on, is memory leaks in your application, causing the browser to slow down and potentially crash at the end. All of these errors I described today using Track.js as an error monitoring tool. So Track.js is a service that I helped build. We've been running at it for 2.5 years. It's a JavaScript error monitoring tool for modern web applications. We support all the major frameworks. What Track.js gives you is we give you these high-level trends on what are the kind of errors that are happening in production for your app. What are the things that are growing? What are the things that have been fixed and are fading away? What are the top 10 errors that are occurring in your app right now or the troublesome users or browsers? And when we have an error that we think you should fix, we give you these awesome amount of telemetry information about what was going on. Because JavaScript errors suck, and they don't tell you enough information about how to fix them. And so we capture all kinds of interesting things about what network events were happening leading up to it, what sort of console messages were being printed, what sort of network things were happening. And we give you this story about here was everything the user did that led up to the error. So if your application is looking for a new sheriff, you should look up Track.js. And that was JavaScript Forensics.
Okay, we're unmuted, so don't talk because then you'll have the echo. But I think every
I apologize that I had to skip through a couple. I am not good at time management, apparently.
That's all right. Really appreciate you talking up from the Midwest, and again, really great information. And the button was the async button, correct? Because I think it was a little hard to see. You couldn't point to your screen, but that was for the third error or something. Was the async button? It's like a click box, checkbox.
Oh, this thing. All right. So here in Chrome Developer Tools, if you're in the sources section and you like open things up, there's this middle or the bottom half where you see your call stack and your breakpoints is this little checkbox right here.
Got it. Cool. That's all. Just want to make sure people saw that.
Yes, it's amazing.
Cool. Okay. Well, thank you for presenting. I wish we could do time for questions and answers, but I don't think we have enough time for that tonight. Again, thanks for the last minute presentation. He was scheduled, Todd was scheduled to talk next month, but helped out tonight since our original speaker had a bad bronchitis thing go on. So thanks again, Todd, and have a great one.
Thank you. If there's any like follow-up questions, or if you're interested in a longer version of this talk that I have recorded, you can either hit me up on Twitter, Todd H. Gardner, or email me, todd@trackjs.com. I'd happily set you guys up with that.
Cool. Any upcoming conferences you're going to speak at?
Yeah, I leave next week for Germany. I'm going to JSConf EU. Which is going to be really exciting. And then in November, I'm going to be at Oradev. And that's all that I have lined up for sure.
Cool. I don't think
any conferences that I should be going to?
Submit to JSConf.
I always submit to JSConf. JSConf US never takes me.
Yeah. Well, they're doing their last call in December.
I know.
They're doing one last one, so.
I'll submit to it. We'll see if they take me.
Cool. Have a great one.
You too. Take care.
Bye.
Bye, everybody.